Welcome back. In the previous video, we discussed about descriptive process modeling. In this video, we will discuss about continuous and model-based approaches for software process improvement. A lot of organizations face multitude of problems when it comes to creating high-quality software products. There are, in fact, several reasons for these problems, and a lot of them can be related to processes. For example, like lack of indispensable processes such as sound project management, configuration and change management, and like validation and verification processes. These problems impose significant risks and consequently result in damages to the organization. For example, the risks they might include financial risks or liability risks, the risk of losing important customers, or the risk of losing the organization's good reputation, and so on. In fact, lower quality of the process often leads to bad product quality. So, without better process quality and an understanding of the effects that processes have in a specific development environment, it is difficult to achieve the objectives as far as the quality of the products is concerned. This is true in particular now for processes that rely solely on some sort of high quality process documentation without adapting and improving the processes in the context of the development environment. So, if processes do not evolve with the development context and do not support developers in an adequate way, the resulting product quality often remains low. Past experience with insufficient process quality has motivated the development of software process improvement approaches that address these issues. So these approaches will be discussed in this lecture, and these approaches mainly include model-based software process improvement approaches. They are also known as problem-oriented approaches or top-down approaches. And the second type of approaches is continuous approaches, or they are also called as solution-oriented approaches or bottom-up approaches. So in the upcoming slides, we will discuss about these approaches. So we first discuss the model-based improvement approaches. Model-based software process improvement approaches, for example, ISO IEC 15504, which is also called as a SPICE or CMMI. These approaches compare an organization's processes or methods with a reference model containing proven processes or methods. Such a reference model often contains only requirements for such processes or methods that result from experience collected in successful organizations. Typically, the elements of such a reference model are associated with different levels that are supposed to reflect an organization's different capability or maturity levels. Therefore, this type of model is often called as a capability or maturity model. An assessment, which is also sometimes called as appraisal in model-based approaches, determines to which degree an organization complies with the demands of the respective model, and is typically performed by comparing the processes actually used against the requirements for these processes as stated in the reference model. Here we discuss the benefits of the model-based improvement approaches, and these include creating quality awareness, then measurable goals and process areas, and important base practices, focused improvement actions, and independent assessment. So we discuss each of these one by one. So the first benefit, that creating quality awareness. In fact, model-based approaches can be easily used to create and enforce awareness for quality issues in large organizations, because many different stakeholders, for example, project managers or developers, they're involved in the improvement actions. Then the next benefit is measurable goals. Uh, improvement goals like now reaching a particular maturity level, for example, maturity level 3, can be easily understood independent of technical details, and are thus easier to communicate. Additionally, from the management point of view, reaching a specific capability level can be defined as a clear, measurable, and accessible goal. Then the next benefit is process areas and important best practices. The reference models contain relevant process areas and the maturity levels. They actually prescribe a way to process improvement, which is perceived as being reasonable. Moreover, the models feature the early introduction of important best practices, such as project management practices. Then the next is focused improvement actions. Model-based approaches support the prioritization and selection of the most important improvement measures. Thus, improvement actions which like with high impact can be performed first, and the resulting benefits can be realized within a shorter time frame. Then the next benefit is independent assessment. Assessments are usually performed by external experts, and thus an independent assessment and evaluation of the respective organization is facilitated. Here we discuss the model-based improvement approach called ISO IEC 15504, or this is also called as SPICE. The other two model-based approaches, such as CMM and CMMI, have already been discussed in the previous lectures, so we will not discuss those again here. ISO IEC 15504, often simply called SPICE, which stands for Software Process Improvement and Capability Determination, is an international standard for evaluating and improving an organization's software processes. A SPICE assessment evaluates a defined a subset of 49 SPICE processes, assigning each evaluated process a certain capability level, similar to CMMI's representation. So evaluation is performed using predefined process attributes. So like CMMI, SPICE also has different capability levels, and it actually has 6 capability levels, that is from like CL0 to CL5. So CL0, which is in fact incomplete. For this level, there are no requirements, and every organization automatically achieves CL0. Then CL1, which is performed at this level, the process exists, and the organization achieves its specific goals to this process. Then at CL2, which is managed. For CL2, the process is managed, that is, it is planned, monitored, and adjusted if needed, and its work products are established, controlled, and maintained. Then CL3 established. At CL3, the process is implemented using a defined process that is capable of achieving its process outcomes. Then CL4, which is predictable. At CL4, the process should be measurable and control. It should have control over the process to operate within defined limits to achieve the desired outcomes of the goals. Then level 5, which is optimizing. At this level, the process is continuously improved to meet the relevant current and projected business goals. So, following a model-based approach helps organizations measure their processes in comparison to some well-established models, and then helps them in devising strategies for improvement accordingly. Here we will discuss continuous improvement approaches. Continuous improvement approaches focus on the important problems of software development organizations and usually involve improvement cycles like plan, do, check, act, which is also called as PDCA, or quality improvement paradigm based on an initial baseline that defines the respective starting point for each improvement action. Continuous improvement approaches focus on solving a specific problem by first analyzing the problem, then implementing and observing problem-focused improvement actions, and measuring the effects of these actions. The interpretation of the measurement data is used as input for further optimization of the solution. In addition, solving one problem typically reveals further improvement potential in the related areas. Thus, further improvement actions can be defined and an improvement roadmap can be created. There are different types of continuous improvement approaches, such as PDCA cycle, total quality management, total quality control, company-wide quality control, Kaizen, zero defect program, Six Sigma, quality improvement paradigm, and the experience factory. In this video, we will discuss only two widely known approaches, such as PDCA cycle and the TQM. So here we discuss the PDCA cycle. This approach consists of iterative improvement cycles called the PDCA, which actually stands for plan, do, check, act. This is also known as a damming cycle. PDCA is not explicitly focused on software development, but has traditionally been used for various other domains, such as for industrial production and business processes. As mentioned earlier, it consists of a four-step problem-solving process. So the first step is plan. That is, perform a problem or potential analysis, and based on the results, define measurable improvement goals and plan appropriate improvement actions that will allow achieving the defined improvement goals. Additionally, determine the results expected from a successful implementation of the planned improvement actions. Then the second step here is do. That is, here we implement and perform improvement actions. Then the next step is check. That is, analyze the success of the improvement actions. In particular, compare the results of the improvement actions against the uh, observed expected results and record any observed differences. Then the next step is act. Analyze analyze the differences between the actual and the expected results, and determine their causes, and define appropriate means to achieve the expected results. A new cycle may be initiated, for example, for follow-up improvement activities, or with modified improvement activities in the event of failure. The PDCA cycle represents a very basic approach for performing the continuous improvement, and in fact is the basis for organizational frameworks of total quality management. Here we discuss another approach for continuous improvement, which is called total quality management, that is TQM. TQM is a holistic management approach toward quality management, and in particular, a continuous improvement within an organization. The TQM approach was mainly developed in the context of industrial production processes. Although classic production processes and software development processes, they do differ, it was possible to transfer basic TQM concepts to the domain of software development. The objective of TQM is to have an organization achieve its long-term goals by focusing on customer satisfaction. So a definition highlighting these characteristics of TQM is that here is in fact the definition that we will see, and it states that all work is seen as a process, and a total quality management is a continuous process of improvement for individuals, groups of people, and whole organizations. What makes total quality management different from other management processes is the concentrated focus on continuous improvement. Total quality management is not a quick management fix. It is about changing the way things are done within the organization's lifetime. This figure shows the evolutionary development of TQM from inspection to quality control, and then to quality assurance, and finally to the TQM. Uh, in brief, the main focus of an inspection is to identify and sort out products with defects. Then quality control introduces a broader view of quality, and provides the methods such as like product testing, basic quality planning for quality improvement. Then quality assurance then starts to focus on the prevention of defects and on statistical process control. Finally, the TQM takes a holistic approach to the subject of quality. So here, in fact, total means that customers, employees across all the departments, and the overall organizational environment need to be considered here. So the continuous approaches for process improvement are used to develop company-specific solutions for important problems, and assess the effects of improvement actions, and emphasize on repeating the improvement practices till the desired objectives are achieved. So that's all about our discussion on the model-based and continuous improvement approaches. This also concludes our lecture. Thank you. The material in this video is based on the book titled Software Process Definition and Management. For more details, you can consult this book. Thank you.